Hi. So today I'll be going over on Leetcode's 150 problems for interviews. The first one being two sum. The point of these videos are just to get more better at explaining stuff and being more confident in talking during interviews. So yeah, let's get started with the Leetcode's first question, which is two sum. So first, let's just read the prompt, which is given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input will have exactly one solution and you may not use the same element twice. You can return the answer in any order. All right, so before I jump into problems, I like to first write our inputs and outputs in like a comment above. So let's first do that. So our input is going to be basically an array of integers and then a target value, which is an integer. And our output should be also an array of integers, but it's going to be the indices that add up to target. All right, from here, I like to then write out the question in my own words. So let's write that here, question in own words. And I would say that we are given a numbers array and we are looking for two elements that add up to the target array. From there, we want to return the index of these elements. So the reason I like writing the question in my own words is just to have a better, just to make sure I have a good understanding of the problem. So in case this one was an interview, I could reiterate the problem in my own words and then see if the interviewer agrees or disagrees with it. So that would be my first steps. The second step would be to talk about constraints. Luckily for us, the constraints are giving to us right here. But let's just pretend this is an interview and let's just come up with our own constraints. So it's a lot easier when they already gave us some. So I guess my first one would be will there always be a element that adds up to target? Second one would probably be will we always have a valid numbers array or target? And this is basically saying it is numbers always is the array of that's passed in here. Is it always going to be an array of integers, because it could possibly be an array of strings, and then we have to take care of in an edge case like that. So I like to make sure that I have all the constraints listed before attempting the problem. After this, I would then want to write some test cases. Usually people do this in the end, but I think it's more important to write it in the beginning because it also shows how well you understand the problem. So let's copy the first input, which is going to be 2, 7, 11, 15. And for this, we should get 0 and 1 because we're adding 2 and 7, and that gives us 9. And we just want the indices, so it's the first element and the second, which is 0 and 1. Now let's write a second test case, which is going to be, let's do something like 5 and 15, which would be 20. So our target is 20, and we need to the two values that add up to that is going to be 5 and 15. So it's going to be 0, 1. So output should be 1, and then 2, and then 3, and then the last element should be 3. Yeah, another possible edge case would be something like if we're having two elements that are the same, so 1 and 1. So our target would be 2, and our output should be 0 and 1. The trick with this one is that since both of these elements are the same, it says here we can't use the same element twice, but this makes sure that you have to be careful with the way you write it in your code to make sure these two aren't labeled the same essentially, because they are the same element, but they're in different indexes. So yeah, I think that's all for inputs. Now I like to talk about possible solutions. So our first solution is the brute force way, which is using two for loops and checking each iteration whether it adds up to whether the elements add up to target. And then yeah, that's basically it for the first solution, is just using two for loops. The issue with this is that it's the time complexity is O of n squared, which is pretty slow. And then I believe our space though is O of 1 because we're not creating any extra memory. The second solution would be to use a hash map. And with the hash map, we only need one for loop, but we just store each element of the numbers array into the hash map. And when we loop over the so let me actually write this around, write this out. So it's going to be a hash map, and then we're gonna loop over the numbers array. Then we're gonna check if the element, or no, we're gonna create a variable. So create a variable that calculates the difference between the current element and the target element. So create a variable that calculates the difference between between the current element and target element. And from there, what we would do here is we're gonna check if the difference, which is this variable right here, is in the hash map already. And if it is, that means we have the two numbers that add up to give us the target. So from there, we'll just return the indexes of those. And then after that, we want to store the current iterations the current iterations element. So store current element in hash map. The reason we're storing it on here and not up here is because let's say our target, let's just write an example. So let's say our target is 4. So target is 4 and our input is 2 and 2. This would actually end up returning 0 and 0. The reason being is because since we already saved it in the beginning, that means the element that we needed is already in our hash map. So it's just going to reuse that element. So that's the reason we store it at the bottom. So that it checks it after it's here. So the correct answer would be 0 and 1, but if we don't store it at the end, it's gonna end up being 0 and 0, and that's gonna use the same element, which is something we're not supposed to do. So yeah, after that, we can actually start by writing out the code now. So let's write our hash map, so equal to an empty object, and then we just want to loop over the numbers array. So let's do for let I equals 0 if I is less than nums.length I plus plus. All right, from here we want to create our variable that calculates the difference. So we'll do const difference, and then let's make this a constant as well because we're not reassigning it. So, and let's abbreviate this to diff just to make it shorter. So we're gonna subtract target, and we're gonna subtract it by nums.I, which is the current element. And here is where we do our check for the two elements. So we're gonna do if hash map at diff is not equal to undefined, meaning that it's inside the element. And all we want to return is an array, which is the output is provided here in an array. So that's why we're returning it in an array. So it's gonna be a hash map at diff, and then it's gonna be I. The reason we write this before I is because this element was before I, because we're gonna store it down here. So let me write that second part first so it makes more sense. So in here, we're gonna store the current element in case we don't reach this if statement. Since we're returning, the function would stop here anyways. So nums at I, we're gonna see equal to I. The reason we're setting it equal to I is because we just want to get the index of it. So this would be the index when we call this of that current number. And I would be the current iteration. And yeah, that should be it for our problem. Let me just make sure. Yeah, so let's try submitting it. Yeah, it looks like that worked. Let's try our test cases that we created. So we created, let's just copy it here, 2, 5, 11, 15. And we're looking for 20. And let's see if we get the correct indices. So 1 and 3, yeah, so 0, 1, which is this one, then 2, and then 3, which is 15. Awesome. So I think that should be it for this problem. So let's just try submitting it. Yeah, and it looks like that works correctly. So the time complexity for this will actually be O of n, because we're only iterating through the numbers array once. And the reason it's O of n is because it could keep on growing depending on the input. And the space complexity would be, let me actually write it down. So time complexity is O of n, and space complexity will be O of n as well, because we're creating a hash map, and the hash map is going to keep on growing depending on how long the array provided is. So yeah, that's it for this problem. I'll leave my LinkedIn on the descriptions in case anyone wants to connect. And yeah, thanks for watching.